Dear students, as we have discussed about the various types of signal generation method, today we will discuss about how these signals are analyzed. The analysis of electrical signal is used in many applications. The electronic instrument used to analyze wave is called wave analyzer. It is also called signal analyzer since the term signal and wave can be interchangeably used frequently. We can represent the periodic signal as sum of the two terms, DC component and series of sinusoidal harmonics. So, analyzation of a periodic signal is analyzation of the harmonic components present in it. A wave analyzer is an instrument designed to measure the relative amplitudes of signal frequency components in a complex or distorted waveform. The analysis is in the frequency domain and can be done with a set of tuned filters and a voltmeter. Wave analyzer is also called frequency selective voltmeter or selective level voltmeters. The instrument is tuned to the frequency of the component whose amplitude is to be measured. We can see the block diagram of a basic wave analyzer. A wave analyzer is an instrument designed for measuring the relative amplitudes of single frequency components in a complex or distorted waveform. Basically, this instrument act as a frequency selective voltmeter, which is tuned to the frequency of one signal component while rejecting all the other signal components. The amplitude is indicated either by a suitable voltmeter or a CRO. Here in this block diagram, the basic wave analyzer is shown. It has some parts which are described as: first one is the primary detector. This is a simple LC circuit. It's adjusted for resonance at the frequency of the particular harmonic component to be measured. Second one is the full wave rectifier. It is an intermediate stage of the basic wave analyzer and it obtains the average value of the input signal. Third one is the indicating device. The indicating device is a simple DC voltmeter that is calibrated to read the peak value of the sinusoidal input voltage. The LC circuit is tuned to a single frequency of the input signal and reject all other frequencies. Now we will discuss about the working of the basic wave analyzer, that how it works. It has a LC circuit which will pass only the frequency for which it is tuned and it will reject all other frequencies. The tuned frequency is passed through full wave rectifier to obtain the average value of the input signal. The output of the rectifier is directly given to DC voltmeter that is calibrated to read the peak value of the sinusoidal input signal. After the measurement of one harmonic component, the resonant circuit is tuned to another harmonic component for measurement. In this way, the basic wave analyzer works. Actually, the wave analyzers are divided into two categories according to their frequency range. These two categories are: first one is the frequency selective wave analyzer, which work on the audio frequency range, and second one is the heterodyne wave analyzer, which is used for the radio frequency range. Frequency selective wave analyzer. The frequency selective wave analyzer is used for measurement in the audio frequency range, that is from 20 Hz to 20 kHz. The block diagram of the frequency selective analyzer is shown, which consists of a narrow band filter section that can be tuned to a particular frequency, and its block diagram consists of an attenuator, drive amplifier, high Q active filter, meter circuit, and buffer amplifier. We can see the block diagram of frequency selective wave analyzer as we have discussed, that it consists of an attenuator, drive amplifier, high Q active filter, meter circuit, and buffer amplifier. Actually, how the frequency selective wave analyzer works: it works on the principle of the frequency selective voltmeter. It is tuned to the frequency of one signal and reject all other signal components and used for measurement in the audio frequency range. It has a filter section with a very narrow passband so that frequency can be tuned. Now we'll discuss about the construction and working of the frequency selective wave analyzer, that how it works. The waveform which is to be analyzed is applied to an input attenuator. it as a range switch and allow a large range of signal amplitudes to be analyzed without loading the amplifier. The driver amplifier feeds the waveform to a high Q active filter. The filter consists of a cascaded arrangement of RC resonant sections and filter amplifiers. The entire AF range is covered in decade steps by the switching capacitors in the RC sections. Closed tolerance polyester capacitors are used for selecting the frequency ranges, and the potentiometers are used to tune the filter to any desired frequency within the selected passband. The final amplifier supplies the selected signal to the meter circuit and also to an untuned buffer amplifier. The meter is driven by average reading rectifier type detector and has several voltage ranges as well as decibel scale marked on it. And this selected signal is also applied to untuned buffer amplifier after passing through final amplifier stage. The main function of the buffer amplifier is to drive output devices such as recorders or electronic counters. The bandwidth of the instrument is very small, typical 1% of the selected frequency.